Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today, I will talk about influence of additive to biodiesel plants based on two articles. First is article of Professor Praved Kumar from Borega University in Ethiopia, which is published in recent number of SME Journal of Research of Energy Resources Technology, Performance and Emission Characteristic for Karanja biodiesel blends assisted with green hydrogen fuel and nanoparticles, and this will be compared with influence of additive mixed ethanol biodiesel blends on diesel engine characteristics, published in Alexandria Engineering Journal in March this year, and was published by Professor Syed M. Eldin from Cairo University with cooperation with uh, Indian Institute of Technology in Dhanbad. The Professor Pavan Kumar is using this four-valve engine focus on hydrogen production, one and an evaluation influence of hydrogen production engine using to biofuel from algas and arnica oil, addition of nanoparticles, nanoparticles of 15 ppm, and how it works. When the Professor Aldin add nanoparticles and, and to ethanol and show how it works. In case in case of work, we get of Pavan Kumar, the hydrogen was focused because it's very important and no carbon dioxide in combustion, just water, reducing and curtailing the carbon dioxide emission by utilizing it. And but it is produced can be by biomass, but is working problem. And the trouble is that biomass combustion as Karanja produce much nitrogen oxide. Similarly, similarly, and even more than in traditional fuel. This case is trying to remove by addition of aluminum oxide. The similar part of emission of aluminum oxide give in case of ethanol Professor Eldin. The Professor Eldin work shows that ignition, the trouble of ethanol is still an addition of aluminum give little bit less on the level of traditional fuel, but still the trouble in case of ethanol fuel is that it from biofuel, from algas and caranja gives still the trouble that rate of combustion and using thicker and monoxide on the level of carbon dioxide is little bit less, but it's give that the trouble is still that blends the efficiency of fuel decrease with the using. So if half of tank is used, the biodiesel is combusted and utilized much faster, thus leading to low volumetric efficiency and than traditional fuel. This is causes that here we have, in the case of Karanja, adding the case how it would compare if, in case of not to ethanol but to hydrogen, we add this aluminium. Would it be better or less, like in ethanol case? So we have we adding this in percenting of Karanja with different concentration of blending nanoparticles with biodiesel, and this goes checking by fuel tank and addition to these nanoparticles and analyzing how is it ghosting. There was checked with diesel and addition. The in case of the load conditions and the experimental test for break specific fuel consumption, we get that in case of different fuel, the addition was still giving the as case of brakes efficiency. The diesel give much higher, just additional of 20 on 40 of ppm gives some impression, but still much lower that only Karanja hydrogen and diesel hydrogen and diesel to hydrogen. This is causing that in case of emission of nitrogen oxide, the actual load condition depending up to load conditions. In case of load conditions that is up to half of tank, the additions of Karanja and nanoparticles of 20 and 40, especially 40, give recent advantages, recent lowering of nitrogen oxide emission. And in case of 80% of reduction was very similar. This was the trouble point, that beside the 80% of using, the Karanja fuel give much more. So unlike the ethanol, bioethanol and diesel or bioethanol fuel, the nitrogen and mixing in hydrogen case, the aluminum nanoparticles improve sufficiently emission, similarly to carbon dioxide emission, like in case of ethanol, and sufficiently 5 times even carbon monoxide. So adding aluminum oxide to Karanja addition with biofuels include lower emission of carbon monoxide and nitrogen monoxide significantly. Therefore, we need that should add this the good case in case of hydrogen fuel. So we see that producing and combusting the producing from biomass to hydrogen production and hydrogen and biodiesel combustion is much more simpler than in case of ethanol. So we need to introduce more quicker hydrogen for system addition to resolve this trouble. So this is showing that hydrogen combustion engines are very important and factor of designing and building environmental friendly engines. Thank you very much for listening to me.